You made it from part 1 into part 2. Great job. All right. The Industrial Revolution is also characterized by innovations that increased productivity and drove industrialization. 5 main innovations helped spur industrialization. 1. Mass production through the division of labor. 2. New machines and mechanization. 3. An increase in iron manufacturing. 4. The steam engine. And 5. A communications revolution in the creation of the telegraph. Now, I want to take a moment to note that China was able to do 3 of these things way back during the Song Dynasty. I'm talking 960 to 1279 AD, folks. But they did not develop steam power or harness the power of electricity. So let's take each of these 5 innovations one by one. So let's talk about this guy, Josiah Wedgwood, and the artist Renoir. Now, stay with me. Renoir, you might have heard of him, he was an artist. He got his start as an artist by painting designs onto porcelain plates. He was an artisan and was paid a nice salary for what he did. That was Renoir's way of doing things. And then there was Josiah Wedgwood's way of doing things. Wedgwood started a porcelain company to meet a growing European demand for porcelain, and with trade with the porcelain-rich countries like China and Japan out of reach, this was the perfect opportunity. In order to make his business more efficient, he subdivided the work into repetitive tasks, such as unloading the clay, mixing it, pressing flat pieces, dipping the pieces in glaze, putting handles on cups, packing kilns, and carrying things from one part of the plant to another. This is an example of mass production and the division of labor. Workers became more productive and required fewer skills. Thus, labor costs were lower, and the mass production of goods meant consumers could get things at a lower price. And when that porcelain is for sale and at a lower price compared to a competitor, people generally choose that one. I mean, think of it. If you're at a store, you're buying, coat hangers or something. You can get a 10-pack for $5, or you can get a 10-pack for $8. They're the same hangers. You're probably going to take the cheaper one, right? Yeah, I am. I'm cheap. Anyway, cotton and textiles were the biggest part of the Industrial Revolution. And these also illustrate the role of mechanization. Mechanization means that machines would do the jobs that humans had previously done by hand. Several inventions revolutionized the spinning of cotton thread and allowed British industry to undersell high-quality handmade cotton from India. Remember in the Atlantic World lecture talking about how everyone wanted Indian cotton cloth? Well, now they found a cheaper alternative thanks to the invention of things like the spinning jenny, the power looms, and carding machines. The spinning jenny could spin 8 strings of yarn at a time. That's a huge increase in efficiency than doing it by hand. Power looms and carding machines kept up the production of printed cloth to meet a soaring demand for cheap quality cloth. In India, using traditional methods, it might take 500 hours to spin a pound of cotton. What is that, like 20 days? I don't do math. Mechanized production meant that it only took 80 minutes, 1 hour and 20 minutes to spin a pound of cotton. The increased production again led to decreased prices for consumers. But there's a couple of big downsides to this. 1, manufacturers will turn increasingly towards women and children as the primary workforce in these textile mills. Women and children were more easily intimidated and worked for less money, and they were assumed to be less likely to cause disruptions in the manufacturing process, meaning they're less likely to try to go on strike. The other part of this, and this is huge, is slavery. Along with the invention of the cotton gin, no thank you, Eli Whitney, another industrial mechanization, cotton became America's most valuable cash crop. King cotton became an incredibly powerful tool in Alabama, Mississippi, Louisiana, East Texas, Georgia, parts of Georgia anyway. The Deep South produced 5/6 of the world's total cotton by the late 1850s. 5/6. It's almost no wonder why the South thought they could use cotton for diplomacy to get recognition from the British during the Civil War. But just to reiterate, all of this prosperity of the Industrial Revolution comes on the exploitation of enslaved Africans and African Americans, plus women and children. To be part of the cotton industry was to silently acquiesce to a growing slave power in the United States South. Now let's move on to iron. Iron was nothing new. Iron had been used in Eurasia, Africa, and China for tools, weapons, and household items for over 2,000 years before the Industrial Revolution. So why now? In 1709, a guy named Abraham Darby discovered that a form of coal called coke, which is coal that has impurities removed, could be used for smelting iron, and as we all know, whoever smelt it, dealt it. This form of iron wasn't as high quality, but was cheaper to produce because coal was everywhere in England. In 1784, British inventor Henry Cord created a process that made it possible to produce wrought iron, which was more malleable and softer than regular iron. By 1790, 4/5 of Britain's iron was made with coke, using the Darby method. Britain's iron production rose fast from 17,000 tons in 1740 to 3 million tons in 1844, as much as in the rest of the world put together. The creation of a cheap iron made possible a chance to show off to the world. In 1851, Britain hosted an international exposition. It's really the beginnings of the World's Fair system, at a place called the Crystal Palace. And correct me if I'm wrong, sports fans, but there is a Premier League team, right, called Crystal Palace? Or the soccer team, I don't know. I don't do soccer. The building was made entirely out of iron and glass. The Crystal Palace, that is. Cheap iron also made possible a revolution in manufacturing through the creation of interchangeable parts. Now, interchangeable parts are fairly common. If you think about like a car, right? If my car breaks down, I can go to AutoZone and I can buy a part to fix it. If a light bulb burns out, I can go get a part to fix it. The part that I buy at the auto store will be virtually the exact same as the original part. Now, Colt Firearms usually gets the most notoriety for this than just about any other manufacturer. In fact, the system of interchangeable parts was sometimes known as the American system of manufacturers because America lagged behind in the number of skilled artisans. Steam power symbolized and powered the Industrial Revolution. Thomas Newcomen developed the first practical steam engine in an effort to pump water out of mines, and pumping water out of mines is going to drive a lot of inventions, I guess. In 1764, a guy named James Watt in Glasgow, Scotland, built off of the Newcomen steam engine to create a new kind of steam engine that could actually be commercialized. This steam engine also was created to pump water from mines. The steam engine could then be adapted to other uses. In fact, Robert Fulton in New York applied steam in a different way, in creating the first steamboat. Soon, steamboats were launched on the Ohio and Mississippi rivers, bringing goods and people up and down the river. Now, I think in the United States, we kind of have this romantic view of steamboats. Kind of like Mark Twain, just kind of passing time on the river. But steamboats were incredibly dangerous, and they could be a harbinger of death, or virtual death. They could explode, they could sink, or they could be the couriers of slavery. As northern states started to gradually eliminate slavery, or if northern or upper South slave owners wanted to punish enslaved people for resisting, as northern states gradually sought to eliminate slavery, or as slaveholders might try to punish enslaved people for resisting slavery, they might be sold downriver to cotton plantations of the Deep South, in which many cases that was tantamount to a death sentence. Ocean-going steam-powered ships were much more difficult to build than riverboats, and the first steam engines required so much coal that no ship could carry more than a few days' supply. 201 years ago, in 1819, a ship called the Savannah was one of the first steamships to cross the Atlantic Ocean, but steam was really a minor part of it. But in 1838, a ship called the Great Western and a ship called the Sirius, which was named for the Dog Star, crossed the Atlantic on steam power alone. Now, this has absolutely nothing to do with anything. Just taking a time out again. In Mammoth Cave, all right, my dissertation to get my PhD was about Mammoth Cave. I was talking about the exploration of the cave. And there was a part of the cave that was discovered around 1838. And there is a cave feature in that passage called the Bow of the Great Western. It's this bend in the cave passage, and when you're underground, you're in the dark, you're carrying a lantern. When viewed from a right angle, it looks like the bow of a ship. Again, nothing to do with anything, just kind of a fun story, or I think it's fun. One more thing. Steam engines eventually get applied to land-based transportation, and that's right, I'm talking about railroads. Between 1830 and 1850, a railroad building mania swept Britain. The first lines linked towns and mines together with the nearest harbor or waterway. Railroads were faster, cheaper, and more comfortable than stagecoaches, and weren't as dependent on weather to run. Railroads, of course, have a huge effect in the United States as well. Railroads opened up the West to white settlement, led to the destruction of the bison, brought in Chinese immigrants, displaced Native Americans, and opened the interior of the country to ports for shipping and trade. In the rest of Europe, railroads helped to accelerate the industrialization of France, Prussia, Belgium, and Germany. Steam produced a transportation revolution, but it was the harnessing of electricity that produced a communication revolution. The first practical electrical telegraph systems were developed almost simultaneously in England and in America. In 1837 in England, Charles Wheatstone and William Cooke introduced a 5-wire telegraph, while American Samuel Morse used a magnetic telegraph to send a series of dots and dashes that could be transmitted over a single wire. Morse's reasons for pursuing a faster mode of communication were downright personal. By trade, Morse was an artist. He was actually working in Washington, D.C. when he got word that his wife in Massachusetts was gravely ill and he needed to return home. By the time he was able to get up there, however, remember this is before railroads, his wife was already dead and had been buried. He never got a chance to say goodbye. Morse borrowed heavily from a scientist named Joseph Henry, who later became the head of the Smithsonian Institution, to create his patented telegraph. And I gotta tell you a quick story here, just because it's hilarious. Joseph Henry, the future head of the Smithsonian, hated Samuel Morse. They hated each other's guts. And when Samuel Morse died, James Garfield, who was a congressman at the time, he would later be the 20th president of the United States, he was asked to speak at Samuel Morse's funeral. And Garfield was also friends with Joseph Henry, and so he writes to Joseph Henry, he's like, hey, are you okay if I, do this? What do you guys think? Should he have spoken at the funeral or not? Go ahead and put your answer in the comments below. In 1844, Morse demonstrated his invention to Congress, hoping to secure startup funding to install telegraph wires and stations up and down the eastern seaboard. From the Supreme Court chamber in the U.S. Capitol, Morse sent 4 words via Morse code to a receiving station in Baltimore. And that is a modern recreation of those dots and dashes. Do you know what it said? New phone, who dis? Oh, they love that joke at the Capitol. The 4 words that Morse sent via code were, "What God hath wrought." It's from the Bible. Anyway, Congress was so impressed they backed his invention, and in the coming years, near instantaneous communication radically changed the spread of news, politics, and communication. People in rural hinterlands of the United States were suddenly brought up to speed with what was going on in Washington, in intimate detail about who said what on the House or Senate floor, as newspapers telegraphed entire speeches into their newspapers. They published these speeches in their newspapers. It was like the C-SPAN of its time. At any rate, in 1851, the first submarine telegraph cable was laid across the English Channel from England to France, which cut the transmission of news from about 4 days into just minutes. In the 1850s, for about 3 weeks, there was a transatlantic cable, but it didn't hold up. Later attempts in the 1860s worked a little bit longer, and this is true. Today we actually have internet cables strung across the ocean. Hope those don't get cut. All right, so we've kind of gone on for a little bit longer here in this lecture. Go ahead, send me your questions, your comments. You can always email me, awarwick@montgomerycollege.edu. I'm also going to be hosting virtual office hours via Zoom. You can find the instructions for that on Blackboard. And if you are enjoying the music, if you're confused by anything, email me, comment, ask questions, talk to your colleagues, talk to your classmates, and we're going to get through this together. Stay tuned for part 3.